Assalamualaikum and good day to Sir Hazimi and fellow viewers. In this video, my group will be presenting the manufacturing process of Lego. My group members are Ahmad Mukriz bin Usolidin, Amir Rizwan bin Muhammad Hakiman, and myself Ana Jasmine binti Harun Nizam, and Hizari Imran bin Khairil Nizam. The most suitable manufacturing process for Lego is injection molding, as all its raw materials was found to be thermoplastics. Within this slide is also the process flowchart. We start with raw material, then heating, then injection molding and cooling, measuring and testing, and lastly, the final product. So, as stated earlier, the most suitable manufacturing method is injection molding. This is due to its choice of raw materials, which consists of thermoplastic granules as seen in this picture here. Some examples are acrylonitrile butadiene styrene, also known as ABS, polypropylene PP, polycarbonate PC, and polyethylene. Some applications of the types of plastics that were mentioned earlier. The first one is polypropylene PP. It is tough but flexible, allowing it to make hinges like the blue book piece here that you see in this picture here. And it also turns white after some time and wear, as you can also see in the picture here, where it is especially thin. Next is polycarbonate PC. It is with PC we are able to make transparent pieces, such as the one we see in this picture here. And it is also a strong material that is able to make ball joints as seen in the picture. Lastly is polyethylene PE. It has a low strength and rigidity as well as a low melting point, but these characteristics are what makes it perfect for large thin parts as the pieces shown here. We move on to the heating process. The granules are first fed into the hopper, as seen in this picture here, and then it is moved into the chamber with the screw. As the granules go deeper, the chamber heats up the granules to around 230 degrees Celsius to 310 degrees Celsius until a toothpaste-like consistency. Once it has become the toothpaste-like consistency, a force equivalent to 29,000 psi or 200 megapascals are exerted onto the material into the die. The paste will then cool instantly and be ejected into a crate. The excess material is also taken back into the system to be ground up and reused. In the next slide, there is a short clip to show this process. As you can see in this short clip, the paste cools instantly and is then ejected into the crates below. You can also see that there is a small claw that takes the excess material to be ground up so that it can be reused to create more Lego pieces. Next, we will be moving on to measuring and testing with Aiman. Thank you.
So now we will move to the safety procedure when operating the injection molding machine. The first safety procedure that we must follow is that we must always wear safety glasses at all times in the workshop. The second safety procedure that we need to follow is that we must always wear appropriate footwear while working in the workshop. The third one is that jewelry and ring must be removed and not be worn while working, as This can cause the jewelry to be stuck to the machine and it can hurt the workers. The next step is that loose and long hair should be contained. So the long hair should be tied neatly or tucked in into the safety jacket. The next safety procedure that we must follow is that clothes and protective clothing must be worn at all times. This also involves gloves, safety boots, and also safety jackets. And the final safety procedure that we must always follow is to switch off the machine when it is not in use. This could help save energy and also not overload the machine. And now we will go to the illustration of the injection molding process. So the first illustration shows us that the plastic granules, which is the orange balls, will be fed via hopper or funnel into a barrel and it is heated into a molten state. The second one shows us that the heated plastic will fill the barrels, which is now the liquidified orange. And after that, the motorized screw will be motorized screw will push the molten plastic to the mold. The third one shows that the screw injects molten plastic at pressure into mold cavity through the gates and also hot runners. The fourth one shows that the plastic product is finally allowed to cool and also solidify before it is being ejected from the open mold. That's all for me. Now we will go to the advantage and disadvantage.
So the advantages of thermoplastic is, first one, it is energy efficient processing. The second one, it has a high volume manufacturing at a lower cost, which means it is beneficial for manufacturers to make the product. The third one, it can be melted repeatedly. Due to the molecular composition, thermoplastic can be heated and cooled many times. And the next one is greater deflection toleration than most metals without deforming. And last one is higher fatigue resistance than most metals. It means it is harder to fail from thermal stresses. So for the disadvantages of thermoplastic, the first one is thermoplastics degrade more easily in direct sunlight or UV exposure, which means we must put the thermoplastic inside of a building and not expose it to the sunlight for a long time. The second one, it can fracture rather than deform under high stress. And the third one, not all thermoplastics resist hydrocarbons, organic solvents, and polar solvents. The last one is some types experience creep under long-term loading. So that's all for advantages and disadvantages. We move on to the defects of thermoplastics.
So now we move to mold injection defects. So for the first defects is flow lines. Flow lines appears as wavy pattern. It generally happens on narrower section of molded components. It also may appear as ring-shaped bands on product surface. How does flow lines happen? The result of variations in the cooling speed of the material as it flows in different direction throughout the mold. So how we prevent flow lines to happen? First, increase the injection speed, pressure, and material temperature to ensure the material fills the mold before cooling. Second, you have to increase the nozzle diameter to raise flow speed and prevent early cooling. For the second defect is sink mark. Sink mark is a depression on surface of molded part. It can occur when the inner part of a molded component shrinks, pulling material from the outside inward. It is likely to happen at thicker part of components. How can sink mark happen? The resulting shrinkage pulls the outside material inward before it can sufficiently cool, leading to a depression. Second, an outer surfaces cool faster than inner, resulting in uneven cooling. How do we prevent sigma? First, increase holding pressure and time to allow material near the part's surface to cool. Second, increase cooling time to limit shrinkage. Third, we have to design a mold with thinner walls to allow faster cooling near surfaces. So for the last defect, we have short shot. Short may occur when the flow of molten material doesn't completely fill the cavities in the mold. Molded component is incomplete after cooling, and short can be classified as major defect. How can it happen? First, narrow or blocked gates that result a restriction of flow. Second, trapped air or gas in molded cavity. How we prevent short? First, we have to ensure gate size is large enough to fill mold cavity. Second, we have to increase the temperature of mold and plastic being injected. It helps to fill mold faster. And for the last one, we have to add an additional air vents or enlarge existing vents in the mold to allow trapped air to escape. And that's all from us. Thank you.